Very good morning, my dear students, respected faculties, and my dear officials. Myself, Dr. Subrata Roy, Associate Professor, presently working in the Department of Commerce, MGCLV. Today, I will discuss about time series econometrics. I have already discussed about panel data econometrics. Today, I shall discuss about time series econometrics. Uh, Now, we were going to the main point. I just want to say what is the research process flowchart. So first of all, define a research problem. Define a research problem. What is the research problem? So after defining the research problem, then you have to collect literature surveys. You have to study literature survey. Actually, two types of literature survey are available. One is related to the theories from which the model or the theory has been developed. Suppose if we want to examine the capital asset pricing model CFEM, you have to know what is capital asset pricing model, who first developed CFEM. So first who developed CFEM is Marquich 1952. After that 1962 Sharp, William Sharp, 1964 Traynor, 1966 again William Sharp, 1972 Pharma, 2002 most probably 2002 Farson and Sage. Those are the developer of CFEM. They have extended the CFEM developed firstly by Marquis. So these are the core paper. So you have to know the theory or model which are exclusively related to your research. These are the core literature survey, core paper. Then you have to find out some empirical research papers which are related to your research problem. Empirical research paper means the researcher used those developed models into their research problem to examine. These are the empirical research paper. So after extensive studies of literature, then research gap have to find out. After find out the research gap, you have to design your research objectives and research questions. So after research objectives and questions, then you have to design your research design. After research design, you have to collect data. It may be primary sources or secondary sources. Then analysis of data by using statistical and econometrical tools and technique. So many tools and technique. Then what you have to do? Then interpretation of result. Then conclusions and finally recommendation. These are the research process. First, now which statistical model you use? Selection of statistical model is very important when you are dealing with time series data. You know that time series data are non-stationary. So you cannot use non-stationary data to your research studies. So you have to convert the non-stationary data into stationary time series data. There are how it is possible. Suppose after developing the series, suppose y is a time series observation. So you observe that the series is stationary in level form. So if your time series is stationary at level, you have to apply, you have to select just simple regressions to examine the long run relationship. Next, after checking, you observe that your time series variables are stationary purely at I0 means level form, I capital I in bracket 0 level form, and I1 means after first difference, I capital I in bracket 1 first difference, or I2 or combination of I0 and I1, not I2, I0 and I1. If this situation arises, you have to select, you have to apply ARDL model to examine the long run as well as short run relationship, autoregressive distributed lag model, ARDL model. Now come to third. You see, you observe that all the variables are stationary at their first differences after taking first differences. If this situation arises, then you have to examine quantification. So quantification is divided into two parts. Unrestricted var model you have to use, or ECM, error correction model, you can choose. So, in case of unrestricted var vector autoregression model, here you can just analyze short run relationship by applying var model. But in case of error correction model, here short run and long run examination is possible. So when you will use ECM, there are two criteria, there are two models also. ECM, single equation model, by considering only two variable bivariate, and the other is when your number of independent variable is more than one, you have to choose VECM model, vector error correction model. And finally, this is the last ways. You see, we observe that the variables are stationary at I0 and some variables are I1, or some variables at I2, not I3. You should not consider I3, maximum I2. If this situation arises, you have to apply Toda-Yamamoto model developed by Toda-Yamamoto in 1995. So, to examine the long-run Ganjar causality among the variables. But one thing, keep in mind that if you find quantification, then apply ECM or VACM. But if you find no quantification, then you should apply VAR model. So, time series is a collection of observations of variable collected through repeated measurement at various times. A time series allows the researcher to identify presumed changes within a population over time. It can also show the impact of cyclical, seasonal, and irregular movement on the data item being measured. Time series can be classified into two different types, stock and flow. Stock. A stock series is a measure of certain attributes at point in time. A flow series is a series which is a measure of activity over a given period of time. So an original time series shows the actual movement in the data over time and includes any movements due to trend, cyclical, seasonal, and irregular events. So one approach to the analysis of time series data involves an attempt to identify the component factors that influence each of the values in a series. This identification procedure is called decomposition. To understand decomposition, we start with the four components of time series. First, trend denoted as capital T. The trend is the component that represents the underlying growth or decline. In a time series, for example, share price changes, technological changes, inflation, productivity increases, etc. This trend is denoted by capital T. Trend. Then come to cyclical. The cyclical component is a series of wave-like fluctuations of cycles of more than 1 year's duration. For example, changing economic conditions generally produce cycles and it is denoted by capital C. Number C. Number 3. Seasonal. Seasonal fluctuations are typically found in quarterly, monthly or weekly data. Seasonal variation refers to a more or less stable pattern of change that appears annually and repeats itself year after year. Suppose during the time of winter, we purchase warm clothes, but during the time of summer, we generally purchase light clothes. Actually, it is changes year after year, and each year it will come again and again. So it is denoted by capital S. Irregular movement. The irregular component consists of unpredictable or random fluctuations. These fluctuations are the result of a numerous of events that individually may not be practically important, but which combined effect could be large and denoted by I. Now the question is how the component of a time series relate to the original series. So this task is accomplished by specifying a model, mathematical model or equation that express the time series variable y in terms of the component t, c, s and I. There are two methods. One is additive method and another is multiplicative method. So additive components model yt, a random variable yt is a time series observation is equal to summation of t plus s plus I. So this model works best when the time series being analyzed has roughly the same variability throughout the length of the series, or in other words, all the values of the series fall essentially within a band of constant which centered on the trend. Now come to multiplicative component model. What's how you will represent multiplicative component model? Suppose yt is the multiplication of s into t to I, and this model works best when the variability of the time series increases with the level. So that is the values of the series spread out as the trend increases, and a set of observations at the appearance of a megaphone or a funnel. So it is possible to convert a multiplicative decomposition to an additive decomposition by working with the logarithm of the data. Suppose log y is equal to log in first bracket t into s into y. Generally, it means log y is equal to log t plus log s log I. It is very simple and I think you know it. So for business and economic time series, it is best to view the trend and cycle as smoothly changing over time. Rarely can we realistically assume that the trend can be represented by some simple function such as a straight line over the whole period for which the time series is observed. However, it is often convenient to fit a trend curve to a time series for two reasons. It provides some indication of the general direction of the observed series. Number two, it can be removed from the original series to get a clearer picture of the seasonality. So if the trend appears to be roughly linear, linearity is important here, linear. That is, it increases or decreases like a straight line. So some key formulas you can use here: time series additive decomposition, time series multiplicative component decomposition, linear trend, quadratic curve, quadratic trend, exponential trend, seasonality adjusted multiplicative decomposition, cyclical irregular component multiplicative decomposition, irregular component multiplicative decomposition, current purchasing power of dollar, deflated dollar value. These are the key formulas generally used in time series movement. Now come to data transformations. Generally, there are three ways: first, log transformation, differentiations, and percentage change. Now come to the first, log transformations. The log transformation yields appealing interpretation of coefficients and model. The interpretation is good for small changes only. The log transformation makes coefficient invariant to rescaling. For example, log y looks more normal than simple y, but log y has a narrower range than y. When and not to log, when you choose log and when you don't choose log. First, you do not take log for zeros and negative signs. If your time series observations are negative sign, you don't take log. Number two, do not take log dummies. Don't use log dummies in your regression model. Number three, potentially large monetary variables are often logged. Suppose income, wages, revenue. These values are very large. 1 lakh per month income is a very large. So if you take log, the value will be diminished. And it is easy to handle also. Number four, large integer values are often logged. Population, number of employees, number of students, each in these cases. Number five, small integer values are usually not age. In case of, suppose you are considering age that ranges between 1 to maximum 100. So it is not necessary to take log. Percentage can be logged or not. Suppose percentage, you can convert percentage into log form or you cannot. So this is not very serious. How to choose? How to choose log? Very important. Sometimes it is unclear which form to choose, and thus we have to first rely on economic theory and previous studies. What previous studies told about it? You have to know. So previous studies is important here. Number two, think about what is implied by particular functional forms for the relevant range of the variables. Number three, don't compare R square that measures goodness of it or adjusted R square if the dependent variable is different. Number four, even in the case of the same dependent variable, that is linear and log linear, hereof selecting the functional form on the sole basis of R square and adjusted R square, selecting the functional form on the basis of fit only gives you an equation that works well for your particular sample. Now come to second method, differentiation. So stationary is an issue for time series econometrics, you know it, and is a precondition to perform regression analysis. Non-stationary time series data should be converted into stationary time series by taking differences. So the data, time series data which is stationary after first differencing is called stationary in order 1, denoted as capital R in bracket 1. Once means one time differences, taking only one time for differencing, make the non-stationary data series into stationary. So what happened? I observed sometimes that some scholars, they actually consider some time series data and run the regression model without testing time series stationarity, normality, autocorrelation, multicollinearity, which are exclusively related to time series data, and they just analyze the result, which is they don't know why I am using this, what is the significance of time series data. So the predictions based on such data will be totally misleading and the result is totally wrong. And in most good journals, if you send such type of paper in refuted journals, your paper will be rejected at desk table. So actually they don't know, they just know how to calculate the value just by using some software, but he don't know the theoretical background regarding why I am using R square, why I am using slope coefficient, what is stationarity, what is multicollinearity, what is normality, what is autocorrelation. They don't know. They don't know why they are using ANOVA. They don't know. So I'm not going to that part. Anyway, now the last one is percentage change. It is calculated by subtracting previous one from the current and divided by the previous one. It is very simple and easy. Here a base year is generally used suppose for 100. So that the percentage changes either increase or decrease. Percentage may be increase or decrease. That depend on your value. Where year can be easily depicted. Any year can be chosen as base year. But generally, recent years are chosen and the other observations are adjusted based on the base year. So today in this video, I'm just discussing these things. So thank you very much for a while being with me. In the next video, I will talk about regression analysis, basically multiple regressions analysis. So thank you very much for a while being with me.